going to do transformations over intersecting lines. And if you've watched my previous video, I did one of these. So we're going to look at Desmos. And right here, we've got a triangle again. We've got some lines. And what we're going to do is we're going to reflect over y equals x first. So real quick, this is y equals x right here. That's a y, that's an x. We're going to do this one first. So we're going to perform a transformation where we reflect over this line, this object. We're going to apply it. Okay, before I move on, I am going to construct this point. So A prime, my first reflection, is 3, 2. So, excuse me, 2, 3. I can do this. So we went 2, 3. Now, I am going to do my second equation, which is going to be this line right here, which is x equals 0, or the x-axis, and this is my second line of reflection. So when I do this, I am going to perform my transformation. I'm going to do a reflection over this line. I'm going to choose this shape to reflect over it. Okay, and I'm going to construct this point right here. I'm just going to show one point for right now. This point right here is a double prime, and it is -2, 3. Is -2, 3. So I want to know a couple of things. One, how would I get, like, what's happening? How do I write this out? How would you see this equation? And I want to know how I got from here to here if I skip the middle. So I'm back here and I'm reflecting over y equals x, then the x-axis, then the y-axis, excuse me, or x equals 0. So remember, this is written just like this. First, we do this one. This one comes first, where this one comes second. It's like parentheses where you do the inside first and then the outside. So it would be written like this, okay? But we know that we're going from A, which is, and I'm going to flip back and forth, is 3, 2. Then we go to A double prime, which is -2, 3. So this is when it's nice to look up on our sheets that we've done before what the formulas are. Because we went from x comma y to, I don't know why that's a capital. I don't want it to be. Oh well. To -y x. So why is that? What happened? Well, if we look up on our chart, hopefully you guys can see that it is a rotation of 90 degrees counterclockwise. What does that mean? How could we predict that? So if we look right here, I'm going to draw a different colored line in from A, and I'm going to make this a different color so I can tell what we're talking about. We'll make it purple. And I'm going to make another line from here to here. And I'm also going to make that purple. Can you guys see that this forms a right angle between them? It formed a right angle. So I went from reflecting here to reflecting there. Well, interesting enough, this forms a 90-degree angle. Here's my first, and I've got it reflected over here. So this bit and this bit are both 45 degrees. Okay. Interesting, right? So what this really means is the result of two intersecting lines is a rotation. Okay? And sometimes moving back and forth is not my favorite thing. So the result is rotation, and the amount of the rotation is 2 times the angle between the two intersecting lines of reflection. Okay? So the amount of rotation in between the two lines, that angle, if we double that, that is going to be the amount of rotation we want. So let's do a couple other examples. So I am going to take a second and erase this. And I'm going to delete these lines and points a little bit. Okay. And I'm just going to do a few examples. So what if we reflect over y equals 0 and then x equals 0? Okay. So here we go. I am first going to reflect over y equals 0. And I don't like where I put that. Why did I put that up so high? I'm going to reflect over y equals 0. That's right here. First. Okay. So we are going to go to our transformations. We're going to do a reflection. We're going to choose this line. We're going to choose the shape. And we're going to apply. Okay. So we're going to create a point. We are going to call this point A prime. And it is, instead of at 3, 2, it is at 3, -2. Now, our second step is we are going to go over x equals 0, this line right here, and we're going to do this second. So remember, we need to do it over the one that has a prime. Okay. So I'm going to do a transformation. I'm going to choose reflection again. I'm going to choose this line, this shape. I'm going to apply. So now I am right here. This is a double prime, and it is 3, -2. So let's look. We are going all the way from here, all the way like that. We're going all the way from here, all the way over to here. Let's think. That looks like how many degrees? You said 180 degrees. You are 100% right. So I'm going to use a segment this time. Maybe it'll make more sense. If we make a line from here to here, a little segment, and I'm going to make this orange. And if we make a little segment from here to here, again, I'm going to make this orange. If we look, that looks like 90 degrees to me. Okay, and more importantly, because that doesn't really matter that much, the thing that matters is that these two lines, the first line and the second line that I did, those are 90 degrees. So we're doubling that distance there. So we can write right in here, if we are doing something, we're doubling the distance. So let's try one where you can't really see it. Let's do an example. So let's say first we are going to reflect over y equals negative x. Then we'll reflect over x equals 0. So it's that little r, x equals 0, because that's the second one we would do. The first one we would do is reflecting over y equals negative x. Okay, so we're doing both of these. Whoop. Let's just choose a point to do it. Let's just choose x comma y. What is happening here? Well, if we do the first one, which we know is the inside, it goes from x comma y to negative y, negative x. And then we know we have to do rx equals 0 and do those points next. So if we do x equals y next, we know that we are going to get y negative x as our answer. Okay. If we look up y negative x, we are going to get 200, we're going to get 270. Reflection of a rotation of 270. That's the same thing. Okay? The distance between these needs to then be about 135. And if we look, we would get that, but we're not going to go through that whole thing because I'm already over. But so that's what it's telling you. Like if you're looking from here to here, that's a rotation of 270. So 2 reflections is going to give you a rotation, and the distance between the 2 lines you're reflecting is going to double that, is going to be the rotation.